value of x in this equation, what do we know? We know that 2 to the 7th power is equal to 128. So immediately we can rewrite this as an equation that says 2 to the power 2x add 2 is equal to 2 to the 7th power. And that means we can equate our indices 2x add 2 is equal to 7. So that gives us 2x is equal to 5. And so x must be equal to 5 over 2. You can check that by substituting it in this index. 5 over 2 times 2 will give us 10 over 2, and 2 is actually 4 over 2, so 10 over 2 add 4 over 2 gives us 14 over 2, which is 7, and that verifies that x is 5 over 2. And this is our next equation. What do we know? We know 3 to the 4th power is equal to 81. But when we look at this index, we have that x is negative. So maybe we should rewrite this as a positive index, which gives us 1 over 3 to the x minus 4. And this is equal to 81. And so we could also rewrite 3 to the 4th using a negative index in this case. So that would be 1 over 3 to the minus 4. And that would be the same as 81. So seeing that we have something in the denominator here, rewrite 81 as 1 over 3 to the negative 4. Now bear in mind we know that 3 to the negative 4, or the inverse of 3 to the negative 4 is actually 81. So we can equate indices here. We have x minus 4 is equal to negative 4. And so x is equal to 4 minus 4, which is 0. And if we check that, we substitute 0 here, we have 1 over 3 to the negative 4, which is the same as what we have on the right hand side, which equates to, with a positive index, equates to the value 81. Here's our next equation. We can see both 8 and 4 are powers of 2, and we also have a negative index here, so maybe we can rewrite the left hand side with a positive index. So we'll have 1 over 8 to the 3x, and we'll use powers of 2 here, so this is 2 squared, 1 over 2 squared. We can rewrite 8 as using a power of 2, so we have 1 over 2 cubed, brackets, and we have 3x on the outside, and that's equal to 1 over 2 squared. Now when we close the brackets, we have 1 over 2 to 9x, and that's equal to 1 over 2 squared. If we equate indices in the denominator here, we have 9x is equal to 2, so x must be equal to 2 over 9. And again we can check this by substituting x in either the original or the simplified version in the second row or the second line. Thanks for watching this video. My name is Alistair. Please like, follow or subscribe for more videos like this. Thanks and bye for now. Hi, here's our question on indices. We're asked to evaluate this without the use of a calculator. So, first of all, let's rewrite this. 4 squared is actually 16, and if we're raising something to a negative index, we can just write it as the inverse, so that'll be 1 over 16, and this is actually the fourth root of 1 over 16, so we can rewrite this as 1 over 16, and we take in the fourth root. And 9 raised to the power of 3 over 2 is the same as 9, the square root of 9, and we'll cube that. And our denominator, we can simplify. This is like taking the square root of a quarter. It is, in fact, taking the square root of a quarter. We'll take the square root of 1, which is 1, and the square root of 4, which is 2. So this evaluates to a half. Our next step is to evaluate what is the fourth root of 16. We know the fourth root of 1 is 1. The fourth root of 16 is 2, because 2 times 2 times 2 times 2 is equal to 16. So this evaluates to a half in the numerator. We know the square root of 9 is 3, and if we cube that, we get 27. And this is all divided by a half. This cancels with this to give us 27. Just to recap, we clear the brackets here using the law of indices by multiplying first what's in the brackets to get 16, and then taking the fourth root. We invert 16 so that we can have a positive index of a quarter instead of minus a quarter. Here we separate 9 to 3 over 2 as 9 to the half, and then that's cubed. Making it a lot easier to evaluate, and in the denominator we're taking the square root of a quarter. In fractions you take the square root of the numerator and also the square root of the denominator. This half, or this square root, applies to both numerator and denominator. That gives you a half. Cancels with a half from this expression, and we're left with 27. And here's another question on indices. We'll clear the brackets here to give us 5 to the 6th power times 5 to the 5 over 6. And like before, we have a negative index, so we can take the inverse of 4, which is 1 over 4, and now we can apply the index of a positive index now to both numerator and denominator. This we can simplify further. We have the same base of 5, so now we can write the base 5 and add the indices, and that gives us 6 over 6, which is 1. 5 to the raised to the 1 is 5, so we can leave that like that. And in the denominator we have the square root of 1 is 1, square root of 4 is 2, so it's 5 divided by a half, which evaluates to 10. So just to recap, we clear the brackets. Because we have the same base of 5, we can add the indices, and that gives us a whole number, 5. 5 raised to the 1, which is 5. In the denominator, we want to evaluate a positive index. So we take the inverse of 4, which is a quarter, and now we have a positive index, which is to raise a quarter to the half, which means taking the square root of both the numerator and denominator, and that gives you a half. So we have 5 divided by a half, it gives us 10. And that's it. My name is Alistair. If you have any questions or comments, please send them to me. Don't forget to like, follow, or subscribe for more videos like this. Thank you. Bye for now. Suppose we have this fraction and we wanted to simplify it or find the value of it, and we didn't have a calculator. Well, here's a quick way of manipulating both positive and negative indices without the use of a calculator. We'll try and keep everything positive, so we'll have the 2 to the 3rd power there. And in the denominator, we'll still have 4 squared, but we'll move the 3 raised to the negative 2 in the denominator, and that becomes 3 squared. And also the 5 raised to negative 1, that becomes just 5. And instead of having this as a negative, with a negative index in the denominator, we'll move this to the numerator, and it becomes 0.3 squared. So just to recap, we're moving the negative indices into the denominator and they become positive, and if we have any negative indices in the denominator, we move it to the numerator, it becomes positive. So we have 3 to the negative 2 becomes 3 squared, 5 to the minus 1 becomes 5, or 5 to the 1, first power, same thing, and 0.3 to negative 2 in the denominator becomes 0.3 squared in the numerator. And now we can go ahead and simplify this. This is 2 to the 3rd power is 8. Now this 0.3 squared is 0.09. Now we have 16, 4 squared, we have 9, and we have 5. Now let's rewrite that here. We have 8 in the numerator, 0.09 over 16 times 9 times 5. Now 16 5s are 80, 80 times 9, we have 720 in the denominator. And 8 times 0.09 will give us 0.72. And further to this, 0.72 is the same as 72 over 100, and that's in the numerator. Now it's 720 over 1 in the denominator. We make that 1 over 720 and multiply it by 72 over 100. Now we can cancel or simplify in this direction. This gives us 10. And now we're left with 1 over 100 times 10, which is 1 over 1,000. Now there are two ways we can express this result. Well, three ways. We have 1,000th. We could also express it as 0.001, or in standard form as 1 times 10 to the minus 3. So all three of these, this, and this, are equivalent. Thanks for watching this video. My name is Alistair. Any questions are welcome. Please like, follow, and subscribe for more videos like this. Bye for now.
Hi, what is the probability that an event occurs? First, let's look at some definitions. An event is a defined occurrence or situation. Tossing a coin and having the tail land upwards, scoring 5 on the throw of a dice, or winning first prize in the lottery. A specific event is represented by a capital letter. Possibility space. This is a set of possible outcomes. There is an implied set of circumstances, and this is made up of several outcomes, including the event. The event is one of the possible ways in which a coin can land. So we have head up, H, or tail up, T. So the possibility space is made up of H and T. Now our definition: probability that an event A occurs. This is defined as the number of ways in which A can happen, and is expressed as a proportion or fraction of the number of ways in which all equally likely or at random events, including A, occur. And it's given as the number of members of the set A divided by the number of members of the set, the possibility space. This is a very important definition, by the way. All other advances of probability theory are derived just from this definition, and a large number of problems can also be solved directly using this definition. The probability that an event occurs must lie between the values 0 and 1. So it must be greater than or equal to 0, or less than or equal to 1. If an event is an absolute certainty, the probability is 1. And if it's an absolute impossibility, the probability is 0. Thanks for watching. My name is Alistair. Bye for now. Hi, welcome to another video in the probability series. The probability of more than one event. There are two categories: either or events. For example, the probability of scoring either 3 or 6 with one throw of a die. The both and events. The probability of selecting both a mango and an apple from a bowl of mixed fruit. A typical event scenario is a probability of obtaining at least one head when 2 coins are tossed. The outcome involves either 2 heads or both 1 head and 1 tail. These two categories we just spoke about fall under 2 headings: mutually exclusive events and independent events. In my next video, I'll be investigating these with some examples. Thanks and bye for now.